Fibonacci and Lucas Identities Part 2 is what we're going to be talking about today. Sorry about that. Alright, so to pick up where we left off in the last video, I believe we had just gotten to the point where I basically was just recapping how I got into finding the Lucas numbers to begin with. So there was a couple numbers that popped up right away that you would find. Obviously the 322 for Fibonacci's number in the first census, and then you do find a number in the differences of the census. In the first census you're going to find 123 pops up. So when we found that number for eagle minus man, that helped us find the moon sidereal, that number happens to reduce down to 123, which is a Lucas number. And of course you're adding that with the 45 from Levi to get the 168, and there's some tied to some calendar work that others have done in 314 that brings in there. But at any rate, that got me down, again, the 233 being the 13th number. I'm seeing all this, the passage of Numbers 2:33 is where we're talking about the Levites, the whole quarter of Israel. That's kind of how I came to know all of this, is from in this first census, right? It was finding this number, setting this corner of the circle to the 90 degrees and making that an even fourth of Israel, and then you find that extra 2250 for Levi in the start, and that kind of gets you going down the path of seeing, kind of finding these numbers in a different way. And again, that 233 popping up not only in the total of 605,800, but also obviously in the quarter of the whole amount, and then finding it in this Judah North portion. And then it's funny, I'm looking at Gematria for 233, and I find this guy here, Israel Hardiman, because I'm looking at different people that have found different Gematrias that are kind of interesting, and he finds this of the tree of life, the Etz HaHaim. This is going to be from Genesis 2:9, I believe. But you'll find Etz HaHaim in here, which is the tree of life. So that comes out to 233. And it's funny that he finds that the tree of the knowledge of good and evil, the second tree, or the third tree, I guess, mentioned in that passage of Genesis, I think it's 2:9, but it's Etz Hadat Tov Urah, which is going to be the tree of knowledge of good and evil, and that comes out to 932, you'll find. So that happens to be 233 times 4. But it's funny when he's talking about this in here, he's not noting any significance of 233. So I'm kind of going the other way. I'm finding 233 being significant, and then going and finding the Gematria. He's finding these particular items in the scripture, and then noting this connection. So just thought that was kind of interesting. But all this gets me down, pointed to 233 into the Fibonacci numbers. And then I start building all of these tables like a mad person. I'm just going through in here, building all of these different tables, trying to find connections to the numbers. And of course, I find this in the powers of phi. I find these connections. So I find that we're adding 4 together, and we're hitting close to that number for 605,800. We're off by 1165 over here. I find these 4 numbers. And then I find the difference of 1165 here. And of course, to me, this can't be coincidence, the fact that you're finding this in these powers of phi. And then, of course, it gets me down to understanding, how we correct these sequences to go from a raw table, a raw data table of powers of phi here, to get to a sort of a clean sequence of this ideal thing that we're basing this off, this being the Lucas sequence, and how we're adding and subtracting on this harmonic to get you closer to this that place that you're ideally going to be at, hovering around. And then in this process, there's some things I start to note, and one of those is going to be, for instance, in these powers of phi, we're also going to note where is it? Some of these other connections that we had made. So again, we have 150, 127. So how far off is this from our pattern of numbers of 151, 450? Well, we end up off by 18, right? So our 151, 45, right? We're going to be off this number, subtracted by this number, off by 18. And then how far are we off? A couple spots down, we're seeing that 39,650 number, which happens to be that number we had for the ecliptic plane. So this number that we find in the first census that is this Judah south portion. Again, that tree of life, right? That Etzha Hayim. This can be also 793 with final form. Also, we talk about that in the Encampment of Israel series, or how we arrived to this particular number. But you know, this all comes from setting Reuben right here, and then finding the difference, pushing this past, how far it goes past this cardinal direction line of east, and finding these bifurcations in the amounts on either sides. Well, 39,650 is right there. So when we go back to this table here, we see how far are we off of 39,650. Again, we're very close to this number, 39,650. How close are we? Well, we're going to be this number minus this number, and of course it's 47. And we see that 47 and 18, again, are going to be numbers in our sequence. So it's sort of nested in here, the difference of these numbers, these special numbers. Of course, this is reduced by a factor of 10. But this gets me down to thinking, okay, building some of these other sequences. And we'll get into the sequence finder here in a minute of this thing that I'm building to kind of find these and draw out these numbers. So again, what this is showing us is that if we take that number of a quarter part of Israel and we reduce it by a factor of 10 to get this 15,145, and we multiply it by phi squared, we're getting to that number that we're finding for that ecliptic in that Judah south. And this number again is we're recognizing is the degree representation for this, 23.56. We know that this number is going to be phi squared times 9. So if we multiply phi squared times 9, we're going to come up with this degree representation for that ecliptic plane number. So we're finding all of this in the numbers. By doing all this work in these book of numbers, we're finding all of these connections. So these nested series, this gets me down a whole nother study of looking at sort of the relationships of nested sequences. And so, yeah, I believe it's this table here. So again, we like we talked about in that last video, we have a nested sequence right here in this sequence that we find that I call the Levi sequence, Uncle Louis. But this 5-to-1 sequence that produces 225 and 364, again, produces these numbers that are very close to 4070 and 6585. How far are they off? Well, they're off by 33 and 53. So that difference is nested into this table. So it got me thinking about some of these other ways that we could nest and look at these tables. And really, you can do it with the Fibonacci sequence itself. So we have if we try to zoom into this a little bit here so we can see this better. But we've got the Fibonacci sequence here, and the nested function. We've got the Fibonacci order here. And okay, this is the number, and this is our growth, our number growth sequence. Well, we see that right here at 987, we're getting dialed into this idea of 1,000, 618, 382. These kind of powers of phi that we see. Remember that our powers of phi here are going to be 16, 18, 26, 18, 42, 36, so on and so forth. And then 1 would be, we're elevating this by 1,000, so this would be 1,000, 16, 18. If you drop down 1, it would be 618. So this got me looking at sort of nesting these orders. So if we take the Fibonacci sequence and then we start it anew at 10 here, So we go 0 and then 1 and add these across. You see we get this adjusted sequence from our base Fibonacci order to 56 to 90 to 146, 236, 382, and then you start to see this, right? 1000, 16, 18, 26, 18, 42, 36, 68, 54. So these are going to be those powers of phi. 11,090, right? This again is that pattern, that 4090 that we saw. That got me down the path of finding that the actual formula for on this table here. On these, well, I won't get into that, but at any rate, you see how we got a nested. You make that small adjustment, you add it back in, so it's almost like you're taking a fraction. You're taking a piece of the sequence, and then you're adding it back in, and then you go down 10 more and you add it back in, and you see how you start to make finer and finer adjustments into something else that's interesting. And that's kind of what I went and I looked at some of these nested functions for instance, the Levi sequence. So we got, yeah. So this is going to be for 605,800. I'm sorry. So again, we found 605,800 by finding those 4 consecutive numbers. But in this particular table, we can just take and multiply the Fibonacci, our base Fibonacci sequence, by 5. And we're going to see that we're going to get those numbers again of that 1165 and 60695. That's just as we had found over here by adding the powers of phi. So adding these 4 up to get to 1165, these 4 up to get to 606,965. So what you start to see is that there's a pattern happening here with these sum sequences, and we'll get into a second, and well, we'll touch on that in a second. I'll just touch on these other where we're kind of nesting these functions in. So again, we're nesting this. We're starting the sequence over at 13, or essentially 14. We're adding in 1, and we're adding in 2, and 3, and 5, and 8, and so on and so forth to get our adjusted sequence to get down to where we're subtracting these numbers out and getting from this number down to this, if that makes sense. And then we can do the same thing with this Levi sequence. So again, we're starting 5, 1. This is going to produce our 225, 364, 40, 37. And again, we knew that we're nesting this in. So starting here again at 10, or 11 essentially, we're adding 1 back in, and 6, 7, 13, so on and so forth. You just add that sequence back in, and you're arriving at this 40, 70, 65, 85 sequence right here that we had found relative to the eclipse. And again, 407, just like we looked at with the 225 and the gematria and the tables, you'll find that this 407 relates to an oat, which means a sign, and that'll be for another study for another day, but look for that video. I'll probably produce something where I'm looking at the gematria of 225 and 407 to find all the significance that's kind of buried in the text of the scriptures there, in the Hebrew, in that base Hebrew. So, and then of course the Lucas sequence, we already looked at this, of getting from your, basically the powers of phi, how we're adjusting that back in and getting to our, we're adding, subtracting in this sort of harmonic way. And there's some tables that I have built in a sort of formula that I'll prepare for the last video of this series, of this Fibonacci and Lucas, which will probably be the next video I do. At any rate, we'll get back over here to take this off for you, and we'll get back into the numbers tool here, and sort of what we had seen in this tool. Again, I'll keep this here so you can see that the sums of what we're finding in some of these. But where were we? Yeah, so we were talking about some of these sums that you're finding. And again, we knew how when you're looking at identities, Fibonacci to Lucas identities, what you'll see is that basically you're going to get the sum of 1, and then you're going to skip one of your sequence of the Fibonacci sequence, and we're adding these two together to get 3. So every other one is going to relate to, again, our Lucas sequence is right here. And it's going to be sort of, so you're adding the first and third term of the Fibonacci sequence to get the second term of the Lucas sequence. So this happens continually. So if we added 144 and we add 377 to that, that comes out to 521. And we see that 521 is the 13th Lucas number. So the 12th and 14th Fibonacci numbers added up become the Lucas number. Well, it's easier to calculate this by just adding 4 consecutive numbers. So just like we found in when we're doing this, that number with the powers, right? When we're actually looking at the powers of this order right here, and we're adding these together. So these 4 together is essentially this count that we get right here is going to be this number, 271,443 times the square root of 5. So you're just kind of carrying this pattern over. So because we're taking the Lucas numbers, which are the Fibonacci numbers times the square root of 5, we're doing this again and multiplying it by the square root of 5 again. The sum that we're getting here is the same as our base Fibonacci order times the square, or times 5, if that makes sense, because we multiply it by the square root of 5 to get the Lucas numbers, and then do this with the Lucas numbers 4 consecutive, multiplying it by the square root of 5 is going to be 5 times your base Fibonacci order. So you're just creating a loop, so to speak, in these numbers. So instead of just adding every other one to get the middle term, again, we're just adding 4 consecutive terms here, sum 7 to get to this number, right? So we can go the fourth, when you add them up and you arrive to the index number that you stop on is going to be the same for the Lucas number, if that makes sense. So 21 plus 34, 55, 89. We're stopping on the 11th Fibonacci number. We see that sum is going to be 199, which is the 11th Lucas number. So it makes it easier to kind of find your index of where you're going from. And like I said, we're adding 4 consecutive Lucas numbers together, and 445 right here. If we divided that by 5, it would come out to, what does that come out to? 89. 89, right? So 89, we look back, and essentially we're going to be that same index number times 5. So it makes it really easy to find some of these numbers. Now, there is a situation in here, and I'll see if I can find it, where you can find that 605,800 number directly. So we get 606,965 here. Maybe it's in, so just by adding from 24 to 12 right here, of these powers, essentially this is going to be powers of 5, or 5 multiplied by 5 for this sequence right here. Because again, we're taking the Lucas sequence, and it's a sum 4. And you do arrive at 605,800, so you can hit that number right here with in this sequence right here, and you get fairly close to 603,550. You're off by a bit there, but at any rate, yeah. So these are just things that you're finding in these sum sequences, and so what I do is, obviously, you're working your way down on these tables, but then you basically project back upwards the other way. So, for instance, you're going to take the sum of this calculation is the sum of 12 consecutive numbers. So all of these, we're at yes, sum of 12 consecutive numbers right here. So you're arriving at this position right here, but to go up to see kind of what your starting interval and your starting number would be for each sequence, you just work it backwards. So you'd be 232 here, your next number is 376, so you just subtract that backwards to get 144, subtract these backwards, obviously, and you just run that calculation all the way back up, subtracting the first from the last, just like you do adding together to get your growth. You're just working it backwards. And you see as soon as you go past 0, that following number, that large number, will be your interval, and this will be your start for a sequence. So you see this sequence right here. This is the sequence right here that will produce a 605,800 divided by 5. So this 2116, if you were to multiply this by 5, you get a 105 and an 80 sequence right here, if you start with those two, and that'll produce your sequence that hits right at 605,800. So all that to say, going through a lot of mechanisms and finding a bunch of different ways that we can actually find value in these given numbers and draw out what we're actually finding. And then to find out what that your starting interval and your start position will give you this idea of what that is. So a 5 to 1 is going to be that Lucas sequence, and then when you multiply it by the square root of 5, or excuse me, that's the Levi sequence. This would be the Levi, the second sequence, or second census sequence. It gives you the 1317, and you see that's an 11.8. And I've got some raw tables here. So these are the clean tables where you have the clean adjusted number. It's going to give you an even number sequence. Very clean numbers, easy to look at. Whereas the raw table, you'll just take this. Again, you're going to find this constant of how far you're off of the base Fibonacci order. And then you're going to multiply this constant through to get your actual sequence of numbers that you're hitting on. So this 1317 again would be that you're 5 to 1 and you're hitting on that fractal of the that 6585. Again, you're hitting at divided by 5. It's just in a very raw number format. So just looking at these tables, multiples of different ways to see if there's something that you can draw out of the numbers of the tails. Again, you know, I'm keying in on this 20 to 1 because I see that's the pattern of the square root of 5. I see that I could just add, essentially I could just add 9 to the square root of 5 and multiply by 10, I think it is. Or do I got that backwards? Yeah, either way, you see it's the same tail as the square root of 5 right there. So you could multiply this by 10 and subtract 9 and get to this number right here. So that's part of the mechanism that I'm doing to find this continual formula that I have right here that works out to find all of these constants. And we'll see how that plays in the last video when I find the that table that I built. So at any rate, so then I get to start building these tables. So I start building this sort of sequence finder table. So just as we found with, for instance, our number for the quarter of Israel, the 150, we find this number, and this table is just going to tell you what this number divided by phi is. And we see it's 93,601. So then if we plug a clean number in here, 93,601, we get this sort of sequence right here. So you see how you get real close to 39,650 right here. Essentially, if this was rounded to an even 100, you'd be dead on 39,650. Right, so we could take this and go 151,445 and 93,60. We'll just go to 93,60 for this and see how we arrive right on 39,650. But you see, once you do this, you're going to run this sequence all the way back to find where your interval and your start number is. And once you go past 0, you're going to see that your interval is 65, your start is 0. So obviously what we have is a multiple of the Fibonacci sequence multiplied by 65. So we can just come over here, we'll reduce this by 65, and we see that we have the Fibonacci order here. At a multiple of 65. 65 would be Adonai, right? That's one of the names for God in the Bible would be that Adonai. So that's kind of interesting that 65 hits there. 650 also, if we were to take 650 and multiply that by 4, we get that 2600 number again, remember? So 2600 being that if we were to multiply this by 233 again, we get that 605800 number. So obviously that's 2600 times the Fibonacci order is going to give us 605800. So this is all kind of letting me see how we're tying into or we're seeing these relationships. So you wouldn't notice in this first census when we're finding this bifurcation of Judah right here, when we're setting this to the 1/4 piece of the whole circle, and we're adding in this other 2250, right, and making this our start point. We're making Reuben our start point on this layout of this camp, because he doesn't excel based off of our understanding of the Genesis 49 blessings. And you start adding this back, and you see that Judah's been pushed this far past the line, right? Because when we add all of these together, we'll see that they're 34,950 more than 151,450, and then that gives us this remainder of Judah. So, is it even possible for this to be coincidence? That this number, the fourth right here, the 151,450 times 5 squared divided by 10 is going to be equal to this number right here. There's just no way. Especially with the Etz Haim, this being the tree of life, and then the Etz, what is it? The Etz Hadot Tovi Ra is the tree of the knowledge of good and evil, being the whole. Again, it's 233 to 932. It's the 1/4. So you're seeing how that ties in again. And the Pakad again with remember, we're singling out some of these. We're singling out Simeon's name with the 466 and 233. It so happens that when you add these together, Issachar and Zebulun together, this is going to be 118. Right here, 111,800, which when you reduce that down by your 50, you're getting 2236. Again, that's a pattern for the square root of 5 with these two. And then again in chapter 2, your Pakad is singling out Issachar, Zebulun, and Reuben as if to keep these 4 together, to point you to this, of creating this sort of ecliptic cross right here. And again, the difference here of 151,450 is going to be 6850. That reduces down to 137. That's going to be our number for the fine structure constant. Right, there's books written on 137 that you can go find. Our pattern and our numbers again being 4.07. Right, again that's the oat. We're talking about a sign happening here. This is a sign 407. This is a sign over here finding 4070 for Levi. When we adjust this total, that's an oat. That's a sign. You can go and look at all of the occurrences of oat in the Old Testament there and find what it's talking about. Again, 137, 822, reduce this by 6, you get 137 again. So the fact that number's popping up on both of these southern bifurcations, you can chalk all this up to coincidence if you want to, but it just seems impossible to be coincidental at some point. So again, what I do is I'm creating this sort of sequence finder and finding these connections to some of these numbers by 5 that you wouldn't normally find. And then when you do, you start recording all of this data. So we're going to come in and say, okay, we're finding a sequence for Judah. We're going to put his number in. We're going to plug it in. We're going to find the preceding number and then find out what our interval and start is. And this you don't always get something prominent in these or something that's going to stick out, but sometimes you do. Obviously Manasseh's number, because you're a Lucas number, you're going to be the Lucas sequence times 100. That's a no-brainer. But like I said, the connection between Levi and what happens in the second census. So I'm looking at the differences. So I'm looking at all the bifurcations in some of these numbers. Looking at the numbers that you're getting for the second census. Simeon's number happens to be a 3-2, a multiple of 40. And if it so happens that if you go down and start looking at some of these things that we see from observation, from empirical science, so I'm punching in the eclipse numbers. So for a one-term eclipse is 6585 again, and we see that it's a 11.8 multiplied by 5. Obviously, we find this with the 4070 6585 number, but for a 3-term eclipse, again, you're multiplying this by 3 and adding 1. You're seeing that this is that same number for Simeon. You're 22 times that same pattern of numbers. If you take this and you cut it in half and get a half-term eclipse, you're seeing that that's going to be the Fibonacci order right here at a multiple of 37. So there's things that are popping out when you kind of do these things to kind of show that there's connections between some of these things. And again, we're seeing it when we're actually laying out this camp, and we're looking at, laying it out in the circle. And this is all coming off of having, again, a round tabernacle in here instead of that rectangular one. So again, to draw out all the meaning of this, it's definitely going to take a lot of people kind of studying, but I think this is definitely going to, there should be evidence enough to see that there's something here. There's something here to how this is, what's going on. Like I said, I don't know if all of this is correct. For instance, in the second census, you see this difference, this Manasseh's number, 52,700. This is the same difference as you have from the man when you add Levi into this 4070. So you end up with this 110,500. Well, we see that the difference between eagle and man now, just like that was our key over here to find that 123 number. You'll see that the difference here again is 52,700. So is this position of Manasseh correct? Should Manasseh be over here? Should these be flipped since they're mentioned differently in the chapter 26? I don't know. This would have to be there'd have to be experimentation. This is the most meaningful way I see it making sense in getting this other bifurcation that makes sense right here. But I don't know. This is going to take, like I said, it'll take a lot more study. We'll see how far I get. But as far as the Lucas and Fibonacci connections, that should, you should be feeling pretty good, I think, about some of these things that we're finding in some of these tables. So there is another, one last thing that I'll provide on this, and I'll have to dig out the formula that I find, and then the table that I built, so that you can easily just punch in and see what sort of sequence relates to the next, because there might be something else hidden as far as the meaning there. But lots to chew on. Hopefully you enjoyed this, and we'll see you in the next one.